Welcome to doassignment-ca. Here is the problem. A boat starts from rest at s equals 0 and travels in a straight line. The acceleration varies as follows. A decreases linearly from 8 feet per second squared to 6 feet per second squared as s goes from 0 to 100 feet, then decreases linearly from 6 feet per second squared to 0 feet per second squared as s goes from 100 feet to 150 feet. Construct the VS graph. Now, let us work through the solution step by step. We start with the fundamental kinematic identity, v dv equals ds. Integrating both sides, v squared equals twice the area under the AS curve from 0 to s. Since the boat starts from rest, the initial velocity is 0, which simplifies everything nicely. On the first segment from s equals 0 to 100 feet, acceleration drops linearly from 8 to 6 feet per second squared. The slope is negative 0.02, giving us a sub 1 of s equals 8 minus 0.02s. Integrating a sub 1 from 0 to s and multiplying by 2 gives v squared equals 16s minus 0.02 squared. Taking the square root, v equals the square root of 16s minus 0.02s squared. At s equals 100 feet, v comes out to approximately 37.42 feet per second. On the second segment from s equals 100 to 150 feet, acceleration drops from 6 to 0 feet per second squared. The slope is negative 0.12, giving a sub 2 of s equals 18 minus 0.12s. For the second segment, we start from v squared equals 1400 at s equals 100, then add twice the integral of a sub 2. Expanding and simplifying gives v squared equals 36s minus 0.12s squared minus 1000. Checking the boundary at s equals 100 feet confirms continuity. Both formulas give the square root of 1400, approximately 37.42 feet per second. At s equals 150 feet, where acceleration reaches 0, velocity reaches its maximum of approximately 41.23 feet per second. To summarize, the VS graph consists of two concave downward curves. Segment 1 runs from 0 to 100 feet, starting at 0 velocity and rising to about 37.4 feet per second. Segment 2 continues from 100 to 150 feet, ending at roughly 41.2 feet per second, where acceleration reaches 0. Both curves are smooth and monotonically increasing because acceleration remains positive throughout the entire motion. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.